unit of a chemical compound that retains the properties of the compound?
Element.
Not element. What did everybody else do?
I got it wrong.
Molecule.
I heard it. It's a molecule. Sorry, Charles. Gotta mute you. Okay, so molecule was number 3. So a molecule is like one precise chemical compound. So something like water is a molecule. It's 2 elements put together to create a chemical compound, like water.
It won't let me do anything.
Yeah, that's because it's
Sorry,
already
submitted it, so I can't really do it.
That's okay. I'm just making sure that you guys completed this one and not taking it for a grade, but from here on out, we're going to do grades on these types of things, okay? So number 4 is a blank is matter that is composed of one kind of atom. So this is just one type of atom. What'd you guys get? Any ideas?
Element.
It is an element. So in this case,
I got electron.
not electron. This one is element. Oops, let me spell it right. Element. An element is just one type of atom, and there's just one type of atom. So iron, hydrogen, oxygen, those are all elements that have one type of atom in them. But when you combine 2 types of elements together, that's when you get a molecule. Okay? The next one, number 5, a negatively charged particle in the atom is the what?
Electron.
The electron. That is correct. Oops, not the electron. Electron.
Yeah, an electron.
That is correct.
Yay.
All right, number 6. A blank is the smallest particle of an element that retains the properties of that element. So it's the building blocks of matter.
Atom.
Yeah, this one is atom.
Atom.
This is an atom. So it's the smallest particle in an element. So one atom, or not one atom, but thousands, millions of atoms make up one element. Number 7. A particle with no charge that is found in an atom is the what? There's no
Neutron.
charge. Good.
Neutron.
No charge is a neutron.
It's neutral.
It is neutral. Neutrons are neutral. Okay. Our next one, an elementary particle that makes up protons and neutrons is what? This one's a weird word.
A quark?
Yeah, quark.
Quark.
A quark?
I got quark.
Like quack, but with an R. Quark.
Oh.
Okay. So those things make up the protons and the neutrons. Then at number 9, the last one, the blank is the core of the atom that it's made up of protons and neutrons.
Nucleus.
Nucleus.
The nucleus. So that's the center of your atom. The protons, you guys can't see me. I was making a visual, but you guys can't see it. Hang on. Let's go back to me real quick. Okay, so in a atom, so can you guys see me a little bit? You good? So in your atom, this is like your nucleus, right? Like my fist would be the nucleus. It's got protons and neutrons in it. And then on the outside, kind of buzzing around in circles and orbits and stuff, is where your electrons are. That make sense?
Mm-hmm.
Yeah, wow. Your new camera, not your camera. Your, what's up?
Look at that one. It's so rotten. It's gonna fall now. It's kind of.
He's totally rolling.
Okay, sorry guys. Was just helping out another teacher. So nucleus has protons and neutrons. You got everything else flying around. Those are the electrons. Okay? So if we go back to our thing, there we go. Presenting. All right, so there was this part here that said new and new. So KNEW means that you already knew the material that was in the video. And then the NEW means that you learned some new things while watching it. Does anybody have any things that they already knew from the video?
Me.
Charles, go ahead. What did you already know?
Okay. So I already knew that about matter and chemicals.
Okay. Anybody else? What did you already know? Marty?
And the nucleus is the core of the atom made up of protons and neutrons.
Cool. Awesome. Anybody else? What did you already know? Anything? All right, what about the next part? What was something new that you learned? What was cool or something awesome that stood out to you? Charles, go ahead.
That there is more room in a bottle with 1 cup of water and 1 cup of rubbing alcohol than 2 cups of water.
Good. So the rubbing alcohol takes up, is it less room than the water? Yeah. So rubbing alcohol takes up less room than water. What else did you guys learn when you watched the Bill Nye video? Michaela, is your hand up? No? Anybody else learn anything new? Alrighty, let's go look at the true false then. I'm already presenting. So if we scroll down to the true and false, I'm just going to write it kind of after. So true or false? Atoms are mostly empty space. You're going to have to unmute. I can't see you.
True.
Good, that one is true. Atoms are mostly empty space. They're really, really, really small, but they're mostly made up of empty space. Okay, number 2. Each element has a specific number of protons in the nucleus. True or false?
True.
True. That one is also true. Oops. True.
It's true that it's true.
It's true that it's true. So each element has a specific number of protons, and that's called its atomic number or its atomic weight. So they always have the same weight or protons in the nucleus. Okay. Number 3. Electrons are the largest particles in the atom. True or false?
False.
Good, that is false. They are not the biggest.
Yay.
I do not remember which ones are the biggest. Do you guys remember?
No.
I don't either. Maybe we'll figure that out. We're going to watch a few videos.
Say what I'm answering. What I answered.
Well, you're right so far. Our next one. A branch of chemistry is named after oxygen.
False.
Yeah, that one's false. There's no branch of chemistry named after oxygen. I don't know why there would be. Oxygen is a chemical, though. Chemical compound. Our next one. Heat is a form of matter.
True.
False.
Well, we got 2 answers there. Anybody else want to break the debate?
It's false. Because
It's
heat
false.
is energies. Heat is energy. So
Okay.
it's false.
Okay, that is true. It is false in this case. They're right. Heat is actually a type of energy, but not a specific type of element. So this one is, of matter. This one is false. Next one, neutrons are negatively charged.
False.
False. That one is false because we know that neutrons are neutral. They have no charge.
Got a minute.
Okay, the next one, number 7. A quark is a small particle that makes up protons and neutrons. True or false?
True.
This one is true. It was up.
Yeah.
True.
That one was up in the top part, right? Okay, our next one. The atomic number tells you the number of electrons in the nucleus.
True.
That is not true. It's not neutrons. Sorry, hang on. Let me go back to it. So it's not the electrons that it's telling you about. It's telling you about the protons. So it's actually going to be false.
You are right about saying so far.
So because it says it right up here, each element has a specific number of protons in the nucleus. So there's no electrons in a nucleus. The electrons float around, not inside. Okay, the next one. Energy is anything that has mass and takes up space. True or false?
False.
False.
Good, that one is false. Energy is not matter. Well, actually, that's what's wrong with this, right? Instead of the word energy, it should say matter. Matter is anything that has mass and takes up space. And our last one. Protons and electrons make up most of the mass of an atom. What do you think?
Let me see.
True?
True.
Yes. So.
This one's kind of a hard one. It's actually false. It's not the protons and electrons that make things up.
False.
The neutrons make up quite a bit of the mass as well. Okay. So there's the answers to those. If you happen to not do that assignment, now you have the answers. Hopefully you were paying attention. Okay.
My sister Kathleen, she went to school, and I think it's not fair because I want to go to school.
Okay. Well, we can talk about that later. Let's stick with the science for now. So I'm gonna need everybody to mute so that we're not hearing all the background noise. We're gonna watch, I think it's 3 videos. They're all brain pop because they just have some good information.
I'm gonna mute myself now.
Yes,
Okay.
please. Thank you, Jada. So we're gonna watch some brain pop videos. Maybe talk about them a little bit after, but we're just kind of doing an overview of atoms and elements and stuff. And then later, well, tomorrow, we're going to do some actual assignments with that. So go ahead and keep yourself muted, and we're going to watch, we're going to start with atoms. So thumbs up. Can you guys still see my screen? All good? All right. Hopefully this isn't too loud. Hopefully you can hear it. We're going to watch this video first.
Dear Tim and Moby, what in the world are atoms? From Chris. What in the world isn't an atom? Air, water, pants, leaves, robots, and humans are all made up of atoms. This is the periodic table of elements, and when you take chemistry, it becomes your best friend. This chart shows and predicts every known element in the universe: oxygen, iron, lead, and so on. These elements are all made of atoms. Around 2,400 years ago, a Greek guy named Democritus argued that everything in the world was made up of particles so small they could not be cut in half. He called these tiny things atoms, from the Greek word atomos, which means indivisible. In the 1800s, another guy named John Dalton refined the idea with his theory that atoms are the smallest particle of an element that retains its chemical properties. That means if you break apart an atom of an element like carbon, it's not carbon anymore. What is it? Well, atoms are made up of even tinier subatomic particles called protons, neutrons, and electrons. The atom's center, or nucleus, is a cluster of protons and neutrons. Protons have a positive electrical charge, and neutrons have no electrical charge. The atom's nucleus is held together by the strong force, which keeps the positively charged protons from repelling each other. The nucleus is surrounded by a cloud of electrons moving near the speed of light. The electrons have a negative charge that attracts them to the protons, and they live in shells representing different energy levels. On the periodic table, atoms are organized by their atomic number, which is really their number of protons or electrons. You can also find the atomic mass here, as well as the element's symbol. I kind of think it's amazing that the difference of a few little protons, electrons, and neutrons can produce such a variety of elements with completely different properties. Different types of atoms can bond together to make molecules. Water is a molecule. It's 2 atoms of hydrogen and 1 atom of oxygen, or H2O for short. You would not believe how small atoms are. It would take nearly 10 million atoms just to cross this dot. And the scale of the atom itself is even more ridiculous. If the nucleus was the size of an apple, the electrons would be 5 whole football fields away. Ow! That means all matter in the universe is mostly made up of empty space, which frankly blows my mind.
Alrighty. So that's our first one. Let me turn off my presentation real quick. So a couple questions. I can see you guys if you have your camera on like you should. So raise your hand if you know the answer. I'm going to ask a few questions based off the video. Who can list the 3 types of particles that are in an atom? What are the 3 types of particles in an atom? Madi, go ahead.
Get your pencils. Protons, neutrons, and electrons.
Good. The 3 types are protons, neutrons, electrons. Next question. Which 2 types of particles are inside the nucleus? Someone besides Madi. Charles, which ones are inside the nucleus?
Neutrons and
Break time, we gotta break time, break time, break time, gotta break time, break time.
protons.
Good. The neutrons and the protons are inside the nucleus.
Up.
Yeah.
So not science guy up. So
Good. So
click.
electrons and protons are inside the nucleus. So then which one's floating around outside the nucleus?
Electrons.
The electrons. Good. Now, someone else, who knows the charges of all 3 particles? So what charge is the proton? What charge is a neutron? And what charge is an electron? Who thinks they can name those? Anyone? Anyone else besides the 2 that have already answered? What if we do one question at a time? What charge is a proton? Who knows what? Dallin?
A positive charge.
Good. Protons are positive. What about neutrons? Someone else? Neutrons are... Okay, Charles, go ahead. Neutrons are...
Neutral.
Good. Neutrons are neutral. And then our last one, electrons are what? It's the only one left. Madi, go ahead.
Negative charge.
Good. Electrons are a negative charge. So there's some good stuff about that one. Let's go ahead and watch another one. We're gonna watch 2 more videos. I might ask a couple questions about the other ones. We'll see. Let me share my screen again. If you're unmuted, go ahead and mute again so that we don't get any mixture of sounds. And we're gonna go watch the atomic model. So this is how the atom had kind of came about. Okay. Let's turn on the captions. And here we go.
Tim and Moby. How do we know what atoms look like if we can't see them? From Darren. Yeah, atoms are small, real small, too small to be seen in any detail. Still, scientists can do experiments that tell them things about what makes up an atom. Right you are, my robot pal. You can't see what's inside the box, but shaking it can give you clues as to what's inside. It's the same with atoms. Using indirect means, scientists have been able to construct different models of the atom. This atomic model has taken years and years to build, and people still tweak it now and again, hopefully making it more and more accurate. At the beginning of the 19th century, Englishman John Dalton built an atomic model called the atomic theory of matter. According to his theory, each type of matter is made of only one type of atom. Also, each type of atom could be put into a group called an element, and every atom of a given element was identical. For example, gold atoms make gold, iron atoms make iron, and so on. These atoms were way too small to see. Dalton also believed atoms could not be created, divided into smaller parts, or destroyed. So far, so good. About 100 years after Dalton, British scientist J.J. Thomson discovered the electron. Thomson used a vacuum tube with metal plates at both ends and an electrical source for his experiment. He found that a beam would form between the two plates, the cathode and the anode. Putting a magnet near the beam caused it to bend, which meant that the particles of the beam were electrically charged. Thomson discovered that the cathode rays were made of negatively charged particles, later called electrons. Because matter is mostly neutral, with no net charge, atoms must contain both positive and negative charges that cancel each other out. Thomson stated that negatively charged electrons must be stuck all throughout a positively charged area. Think of it like the atom is cookie dough and the electrons are chocolate chips. The discovery of electrons was a big deal, but it left some questions to be answered. Where were those positive particles holding those electrons in place? In 1909, a New Zealand-born British scientist named Ernest Rutherford and his team set out to answer some of these questions. They beamed positively charged alpha particles at a sheet of really thin gold foil. Because so many particles could pass right through the thin gold foil, Rutherford hypothesized that the gold atoms must be made of mostly empty space. But some of the particles did bounce off, so Rutherford revised his hypothesis to say that a gold atom must have some very small, positively charged mass. He named this mass the nucleus. He called the positively charged nucleus particles protons, and said that the electrons were scattered in empty space around the nucleus. James Chadwick, a student of Rutherford's, found new particles in the nucleus that weren't affected by an electric field at all. Alpha particles in the experiment had knocked them loose. Chadwick called these uncharged particles neutrons. Also in the early 20th century, a Danish physicist named Niels Bohr discovered that electrons are arranged in energy levels. The lower energy levels are closer to the nucleus and can hold just a few electrons. The higher energy levels are farther away and can hold more electrons. Since then, scientists have refined the so-called Bohr model. Electrons have levels, but they don't orbit the nucleus in neat little circles. Instead, they exist in a region called the electron cloud. The atomic model is constantly evolving as scientists discover more and more about what makes the universe tick. Oh, okay. Go ahead and open it. Hey, it's an atomic model. Well, you have to put it together. That's not right.
Alrighty, so that was the other one. We are actually going to read an article in our science class tomorrow, our live lesson tomorrow. You guys will all have a copy of it for you to look at on your computer about the different models. So we'll go a little bit more in depth on it tomorrow, but there's a little introduction for you. And then we're going to do one last video, and then we'll actually be done with science today and live lessons. Yes, Charles, I know it's 1 o'clock, but the class goes until 1:30. They're hour-long lessons, not just half hours. So, one more video. This one is going to be about the periodic table of elements. And later this week, so on Wednesday and Thursday, each of you guys is going to have a specific element to do a little bit of research on your own. and make a PowerPoint on. So pay attention to some of the stuff on here because I'm going to ask you to find some of the stuff about the article. Or not the article, about the element. Okay, does that make sense? So pay attention, know kind of what's coming for the week. So, captions, and here we go.
Dear Tim and Moby, please make a movie about the periodic table of elements. From Lauren. Sure. You're overreacting. It's not that complicated, really. The periodic table of elements may look complicated, but considering it's a list of all the chemical elements that occur in the universe, and then some, it's actually pretty simple. It categorizes elements according to the properties of their atoms. Atoms, you'll remember, are the smallest unit of an element. They're made up of a nucleus composed of protons and neutrons, and a number of electrons orbiting in different shells, or orbitals. It's the numbers of protons, neutrons, and electrons in an element's atoms that determine its properties. That's right, Moby. The configuration of these three particles is the only thing that makes one element different from another. The modern periodic table of elements organizes elements so that it's easier to see how elements relate to one another. Well, first off, the elements are listed by their atomic number, or number of protons in their atomic nuclei. You can find that here, along with the element's symbol, name, and relative atomic mass. You can read across the table this way. Hydrogen has 1 proton, helium has 2, lithium 3, beryllium 4, boron 5, and so on. Reading across this way, the sets are called periods. You remember how electrons orbit in shells, right? Well, periods describe the number of electron shells that elements have. Period 1 consists of only 2 elements, hydrogen and helium. These guys only have 1 electron shell. Period 2 contains elements with 2 electron shells. The first shell contains 2 electrons, and the second one can hold up to 8 electrons. As you read across a period, that outer shell fills up with electrons. So lithium has 1 electron in the outer shell, beryllium has 2 electrons, boron has 3, and so on. By the time you get to the far right side, the outer shell is completely full. The 6th and 7th periods contain so many elements, scientists took some out and put them underneath. Well, the configuration of electrons in an atom's outer shell plays an important role, too. It determines what other kinds of elements it can bond with. On the periodic table, elements with similar configurations of electrons are arranged in vertical columns called groups. Groups are numbered 1 through 18. In some of these groups, the elements don't have that much in common, but that's not always the case. Take a look at group 1. All the elements in this group have exactly 1 electron in their outermost shells. That means they're likely to form positive ions. They're also likely to bond with elements in group 17, whose outer shells are 1 electron shy of being completely full. The periodic table is also organized by color into different categories. These categories are organized by properties of the elements. Alkali metals, like sodium, all can react with water to produce alkaline solutions. Alkaline earth metals, like calcium, also produce alkaline solutions when combined with water and are found all over the place on Earth. Transition metals, like iron, are strong and shiny. Poor metals, such as lead, are soft with low melting points. Semi-metals, like silicon, conduct electricity only under certain conditions and are useful in electronics. Nonmetals have a variety of properties and include the carbon, nitrogen, and oxygen vital to life on Earth. Noble gases like helium and neon have outer electron shells that are full, and so they don't often react with other elements. So there you go, the periodic table of elements. Well, I've seen tables with elements going all the way up to atomic number 118, but any element above 92, uranium, is too unstable to occur in nature and has to be made in a lab. Another cool thing about this table is that because it's based on number of protons, and you can't have half a proton, scientists are pretty sure there aren't any holes in the table. Using an early version of the table, scientists were even able to predict the existence of elements like neon and germanium before they were even discovered. Yeah, see? Well, that wasn't too hard, was it? Yeah, Moby, you give up too easy.
Okay, so there's a lot of information in that one about like all this stuff kind of at the end about different types of metals and things like that. The stuff that you are going to need is more of, where is it? This type of stuff where it tells us the atomic number is 20. This is the symbol for calcium. So this is the kind of stuff you'll need to know, as well as you'll eventually have to draw what it looks like as well. So you don't need all the stuff that was kind of in the second half of the video. That's a little bit more in depth than we need it to be. But the stuff in the first half, just that's based on like what it looks like on the periodic table when you have like its atomic symbol and its number and all that stuff. You're going to need to know that stuff for your little project that you'll do, as well as just some basic facts about the element that you choose. I'm going to let you guys choose. Hopefully, I'll figure out how to do that. But that is all we're going to do for science today.